Hello, this is a lesson on plate tectonics, and particularly earthquakes. And this is important because the movement in plate tectonics manifests itself particularly as earthquakes that can create a big hazard in these tectonically active regions. If we look at the current USGS latest earthquakes repository here, we see that um, in the US here, there's already been uh, this is only showing earthquakes that are 2.5 Richter magnitude above in the US. So there's one here in California um, today, May 25th. Uh, Again, this is in California. So you can see that California already has shown minor earthquakes even today. And this is where the fault lines run through. This is the San Andreas Fault. Um, Similarly, if we look at other parts of the region here in the Pacific, we see that Philippines here has already shown a magnitude 5.3, which is fairly large. And again, these are right along these plate boundaries here. So let's take a review of some of these things. Uh, to start this, let's talk about continental drift. This was an idea proposed by Alfred Wegener. Um, he proposed this idea that all land masses basically migrate, and he said that before 225 million before present, they were basically all part of this giant supercontinent that was called Pangaea. As you can see, these continents kind of fit nicely with these other continents. So South Africa, eastern side fits perfectly with the continent, western coast of the African continent. And slowly he proposed that these landmasses migrated, and we are currently where the continents are presently. So basically today's version is called plate tectonics, basically the theory that the Earth's surface is divided into a number of plates, basically 9 to be exact, that float independently over the mantle of the Earth. And right along where these plates meet or the boundaries occur, that's where we are building mountains, or where that's where the seismic activity is high, causing earthquakes. So here we see the continent uh, and their location at present and the boundaries of the major plates. So 9 plates. Here we are in the North American plate right here, the Caribbean plate, and you can see these are the boundaries of all of these plates. The African plate, the Eurasian plate, and there are several boundaries that are here that are differently labeled here. So for this one here, uh, west coast of South American continent here. This is where this oceanic plate is basically going underneath this continental plate. So you can see this diagram here. This plate is going underneath the South American plate. This is a mid-ocean region where the ocean is actually spreading apart. So we are creating basically new crust here. Here, uh, here we have a continental collision going on here. So this Indian plate here is colliding against the Eurasian plate. This is where we have the biggest mountains as well, the Himalayan mountains. So again, we'll cover this in the next couple of slides again. So again, this is Google Earth, a snapshot. This is the Mariana Trench here, one of the most deepest parts in the ocean here. As you can see, this is also where uh, the plate boundaries are located. So you can see the subduction zone here, one of the most highly volcanically active regions. So as you can see clearly on the ocean surface as well. Now, if you look at the age of the oceanic crust, so red being the youngest, again in millions of years, uh, this bluish purple here becoming the oldest. So as you can see, this is where the mid-oceanic ridge is. This is where the ocean is spreading apart and new crust is being formed. So as you can see, this is some of the youngest parts of the oceanic crust. All of the red is fairly young. Some of the oldest oceanic crust is right along here. So you can see the purple region. So as you can see, you can also see that the age of the crust gets younger as you come towards the oceanic ridge. So how do we form the Earth's crust? How do we, when you look around the Earth, how do you see what the Earth is being formed? two major activities. One is because of the plate tectonics. This is again by the movement of the plates. And the second is weathering and erosion. So this is powered by the sun, air, water, and ice and their movement. So two major reasons. So again, this is showing some of the major coastal crustal formations. So this is what I am mentioning, the oceanic ridge, where the ocean is spreading apart. There's the material, the new crust that's coming and upwelling. In the subduction zones, the oceanic plate is undergoing the continental plate here. So we're actually basically this is where the crust melts and it goes, you know, underneath the lithosphere here. All right, so this is in your Moodle page here, major settings for the tectonics, the major tectonic settings. One is called, the first one is continental collision. So as the name implies, this is where two continents, two land masses basically come together. And as you can see, this is figure here showing a lot of the earthquakes here, very shallow earthquakes. This is the depth of the earthquakes, meaning how far below ground the earthquake has originated. So a lot of frequent large shallow earthquakes. No volcanoes present here. So again, places like the Himalayan range, this is very typical example of continental collision where we have a lot of these shallow large earthquakes also frequent. The second one is subduction zone. So this is, again, I mentioned earlier, this is where the oceanic crust is pushed underneath another section of the crust, also could be an oceanic crust. And this is again showing the earthquake activity in oceanic crust here. This is Aleutian Islands here. So there's a lot of shallow earthquakes, but also there's some deep earthquakes here. And this is also a major reason of considerable volcanic activity. So when one of the crust is undergoing another crust. Also, this could also occur in when the oceanic crust undergoes a continental crust. For instance, west coast of South American continent, where the Nazca plate is undergoing the South American plate in the Andes. The third one is the mid-ocean ridge. This is where we are forming new crust. Often occurs in the middle of the ocean. So again, here the ocean crust is spreading apart. There's moderate earthquake activity, fairly shallow earthquakes, as you can see by the color orange, meaning these are fairly shallow earthquakes. And also these are places where there's considerable submarine volcanic activity and lava formation. So this is, again, a region of high volcanic activity. As you can see, this is from the Jan Mayen Island region. The fourth one is called a transform fall. These are usually long straight features across which two sections of the crust move differently. Again, this is here the Southern California. This is the San Andreas Fault. So here we got fairly long straight features, the San Andreas Fault running through here. Considerable moderate earthquake activity here is indicated by these dots here. Again, this is also present in other areas such as in Anatolia and Turkey as well. The fifth one is a hotspot. So these are again isolated points of volcanic activity. So not necessarily a regular occurring tectonic activity. So as a result, we get these infrequent large earthquakes and sometimes also frequent moderate earthquakes. These are usually also regions of shield volcanoes, so places in Hawaii, not necessarily as hazardous as the other volcanoes that we find in subduction zones. But nonetheless, these create these hotspots. And finally, there's one more called passive, which is where it's completely away from these plate boundaries and hence passive, so we don't see any activity. So again, when we were discussing these plate settings, we talked about mountain regions. Orogenesis is called mountain bedding, so particularly where two continents come together in continental collision. It has been occurring over millions of years, such as the Himalayan range, which started basically being built around 50 million years ago, and they correlate very well with the plate tectonics. So now this is where, again, recapping our major plates here. These are the plate boundaries, the continents here. Now if we put together our volcanoes and earthquakes, so here the orange spots here are volcanoes and hot spots. The triangles here are all volcanoes. The oranges are earthquakes. So as you can see, one thing that pops out is all where we have these boundaries. That's where most of these volcanoes and earthquakes are correlated with. So the plate tectonics explains a lot of this volcanic and earthquake activity globally. Now, we'll also briefly talk about tsunami. It's basically a sea wave of local or distant origin that results from a large-scale seafloor displacement. So the one we saw in Thailand in 2005 when we had a massive earthquake in, underneath the ocean floor that disrupted the seafloor and caused basically a large sea wave that was very hazardous. Now, earthquake is what we'll focus on. Again, various terms outlined here for you to review. Usually we hear this term epicenter, which is the area directly above where the earthquake sort of hit on the ground. We also talk about aftershocks, usually a series of mini earthquakes that occur after the main shock. Okay, so what are the earthquake hazards? We can definitely have a tsunami, as we saw in Thailand. Fires, a lot of times gas pipelines or electrical poles get basically damaged and creating a lot of fire hazards. Structural failure is the one most visible, damaged houses, buildings, highways, and others. Flooding can also happen as a result of earthquakes, particularly from tsunami as well. And landslide, if you are in a very mountainous region, such as in the Himalayan region, because of the earth shaking, can cause a lot of landslides as well. And certainly we need a lot of hazard planning for earthquakes and volcano and tsunamis. So a couple of things we can do is, it's hard to predict when the earthquakes hit. So one thing we can do is hazard mapping. So in case of an earthquake, what are the areas that are going to be damaged the most, or where should we evacuate the people from? So we need an evacuation plan. We need some sort of mapping of the earthquake hazards, and early warning system. So let's say if the earthquake were to hit, either a big siren, as we see in the case of Japan, particularly when the tsunami is here, or these signs. We even see this in Cape Cod in Massachusetts for tsunami. So in some way to basically relay this message that the hazard in the form of an earthquake or a tsunami is coming, either the siren, text messages, any other way. We can also have land use planning, building codes, so that we know that where to shelter, what are the most vulnerable areas within this city, within this town. You can also have auto shut off for gas lines to avoid fires. So when the earthquake hits and when the earth shakes, we can have pipelines, electricity automatically shut off. Right, so various big earthquakes that I've hit. Even in the U.S., we had a massive earthquake in 1964 in Alaska. Not a lot of people know that. Almost basically a significant portion of some of the coastal area basically disappeared here. Also created a tsunami. You can see the travel times of the tsunami generated from the 1964 earthquake. We had a massive earthquake that hit in 2015 in my country, in Nepal. In April 2015, April 25th, 2015, we had a massive earthquake, 7.8. In the epicenter was Gorkha, and you can see here, the epicenter is basically destroyed to the ground. The city of Kathmandu was also hugely damaged. A lot of historical monuments and infrastructure in the city was completely damaged. Death tolls was in thousands. We had another major aftershock after that April 25th shock hit in 12th of May, almost a month later, and that also created a lot of this damage, so it furthered the damage. Haiti earthquake in 2010 is probably one of the most devastating earthquakes that has happened in the last 10 years. 7 point magnitude earthquake that hit in Haiti, but the damage was intense. Even up until today, we don't really know the estimate of the death. The estimate is about 100,000 to 160,000. Death estimates 300,000 injured, millions of people displaced. As you can see, a lot of schools damaged by earthquakes. So again, just to show that even in the last 10 years, we have had some major earthquakes around the world, and particularly in these developing countries like Nepal and Haiti, when we don't have a good hazard plan, we don't have good infrastructure, urban planning. This is where the hazard can damage and create a lot of, basically cause a lot of casualties. So again, this recaps our lecture, mini lecture on earthquakes and hazards. Just before I end up, um, this is part of one of your assignments here. So this is the earthquake regions here, and as you can see, uh, it's also given by state. So I can choose California here. If I look at the hazard map for California, as you can see, this is showing the seismic hazard. So the dark red regions are seismically hazardous, given the presence of the San Andreas fault and also the terrain of this region. Now we can also look at Massachusetts here. And for your assignment, you'll be looking at a couple of the states here. So this is a bit slow here. Right, hazard map. So again, for your assignment, you'll be looking at the number of earthquakes for a couple of states. So again, this is the seismic hazard map for the US. As you can see, not a lot of red areas as in California for Massachusetts here. This is for your assignment that you'll be doing. You can see that there's a tally of all of the earthquakes here for Massachusetts, and I'll let you explore some of these things.